Hi folks, this is part 2 of the same note package. So if you didn't get a note package from yesterday, you want to pick one up from today. The sub should have one. If not, you can follow along with the notes that you have in your booklet. You just won't have the table with the extra spaces in it. Not the end of the world, but it does make it a little bit easier if you have this note package. Okay, so today we're continuing on. Now we're jumping into, we jumped into the world of reciprocal functions. Now we're doing secant graph. This is what we're going to graph today, and we know that it is the reciprocal function of cos. So I've given you the cos table that we use for our basic cos graph, and you can see that the secant table is a little bit more hefty. There's a few more points in it. Just like the cosecant one, I needed more data points. Okay, so what we're going to do with this table right now, we are going to go ahead and we're going to fill in this information. So at negative 2 pi, y was 1, so the reciprocal is 1. At negative 3 pi over 2, it was 0. The reciprocal is going to be 1 over 0. We know that as undefined. And if it's undefined, we know it results in an asymptote on the graph. Negative 1 is still going to be negative 1. 0 turns into an undefined. 0, we were at a positive 1, so it's going to be positive 1. At pi over 2, it is undefined. At pi, we're at a negative 1, and here we're at undefined. Did you find what you need, Friedel? Right up front. Oh yeah, I erased them, sorry. The green one right up front. Okay, and 2 pi was 1, so it's going to be 1 on this one. Sorry, you can't see that. Okay, so like I do with all my graphs is I put my asymptotes on first. I'm going to do my increments. Okay, so just like in the cosecant graph, I needed more information. I'm going to use the same extra points. Oh, I said I was going to graph these, and I'm not doing that. I apologize. Okay, I'm going to graph my asymptotes. Try to keep them as straight as I possibly can. I've been having difficulty with that. Oh, geez. Those aren't my asymptotes. Holy Hannah. Maybe I'm just going to grab a new sheet altogether. I was doing the other graph. All right. Don't do what I just did. All right. It's almost like it never happened. See, I have an extra set of notes. I just got to get caught up with myself. 1, undefined, negative 1, undefined, positive 1, undefined, negative 1, undefined 1. Whew! Okay. Got to catch up with myself. I got to catch up with you guys. My y increments on because I always forget to do that. That's my favorite thing to forget to do. Okay, I'm actually going to read my chart now. And at negative 3 pi over 2, I'm at my first undefined. So negative 3 pi over 2 is halfway. So this is what happens when you do lessons back to back. Negative pi over 2, pi over 2. 3 pi over 2. Okay, so there are my asymptotes. Boy, oh boy, they're crooked, but we'll get through it. Okay, at negative 2 pi, I'm at a positive 1. At negative pi, I'm at a negative 1. At 0, I'm at a positive 1. At pi, I'm at a -1, and 2 pi, I'm back to a 0. All right, so again, we don't have enough information to do this. So what I'm going to do is I'm going to use the same points I used on, oh look, this works out delightfully. I'm going to use the same points that I used on my sine table because I think that's going to help me. So I'm going to start at positive pi over 4. So I'm just going to pop down here. I'm going to put in pi over 4. I'm going to put in 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, so those are all the same increments. Life's pretty good. If I look at, where's my unit circle? If I look for cosine, at pi over 4, so my x coordinate, it's root 2 over 2. We're doing the reciprocal of it. And I did that in my calculator. So 2 divided by root 2 gives me that decimal. So I'm going to use just the decimal again. So 1.41. I find that helps me. And if this helps you to put that, then please do that. Okay? I know at 3 pi over 4, I'm in quadrant 2, so my x will be negative, so it's going to be negative 1.41. I know at 5 pi over 4, I'm in quadrant 3, and my x will be negative. I know in 7 pi over 4, I'm in quadrant 4, so my x will be positive. And again, you can see the pattern. Around the -1, we're going to have negatives 1.41. And around the positives, if we put those in, it's going to be a positive 1.41. Sorry. I'm just going to put my angles in first, just because that makes my brain happier. So negative 5 over 4 pi, negative 7 pi over 4. All right, so I'm going around a -1, so I'm going to be negative 1.41, negative 1.41. And here I have a positive, so I'm going around that, so that's going to be the positive 4.1. Okay, so now I'm going to graph those extra points. I'm trying to find my blue pen on my desk. Okay, so at 0, we were at 1. So at pi over 4, we are a little bit above that. And remember that pi over 4s are just going to be in between the halves. So if you're not sure where to put them, that's where we're going to put them. So right there, we have an asymptote. Then at 3 pi over 4, which is right here, we're going to be at negative 4.1. At 5 pi over 4, we're going to be at negative 4.1. At 7 pi over 4, we're back to the positive. If we go the other direction, this is going to be a positive. This one will be a negative and a negative. And again, you don't have to plot these points. You can follow the pattern. And really what I'm looking for is those parabolas and which direction are they opening. So I put the points all on there, but really what we're looking for is we're looking for the up down. So really I need this. If it's a -1, it's going to open down. And you're like, Scallion, that's the exact same graph we just did. It is. It's super similar, but here's the deal. Is that on a cosecant graph, you have an asymptote along the y-axis. On a secant graph, you don't. It's on the pi over 2. So on a cosecant graph, so it's almost the exact same graph, but it's just shifted. So you have the same values, but these asymptotes start at pi over 2. These asymptotes start at 0. Okay? All right. So let's go through this again. This should be becoming old hat for you. So the amplitude is none. The period, you need an up and a down. So if you have an up and a down, we're going to go from negative pi over 2 to positive 3 pi over 2. And that's a full pi. No, that's a full 2 pi. The domain, again, I'm going to do my equation of the asymptotes first before I do my domain. So theta is going to equal, because it's the equation of the asymptote, so it has the equal sign. And my very first positive asymptote occurs at pi over 2. So pi over 2 plus, asymptotes happen every pi, KEI. All right, so I'm going to go back to my domain. So theta can be any value on the domain. So theta ER, or if you want to put negative infinity to positive infinity, that works too. But we say, but theta cannot be equal to where we have those asymptotes. All right, the range, again, exact same as the other graph. We have this whole swath, we have this whole portion of the graph that can have no y values in them. So we're going to do that in unison statement. We're going to do the down, so the negative infinity to negative 1, negative 1's included, in unison with positive 1 to positive infinity. The zeros of the function, we have none, because it never touches the x-axis. But on this graph, we do have a y-intercept. The y-intercept occurs at 1. So super similar graphs, but everything's just shifted over a little, and therefore we have some, it's similar enough to be super confusing. And that's going to be keeping it straight. So if you can't memorize these, which I totally get, math it out, do your table of values. I know it takes longer, but it won't lead you wrong. So use a table of values. All right, that is your secant graph. And again, I just want to point out all 5 graphs are located on here. And see this dash line on the cosecant graph? That dash line is the sine graph. So you can see the relationship. So where there is a maximum, that's where the reciprocal graph opens up. Where there's a minimum on the sine graph, that's where the reciprocal graph opens down. So you see the relationship between the two, and if you can make stuff connect, then it's gonna stick in your brain a little bit better. So, and same with this one. This is your secant graph. So right there is your y equals cos x graph. So that dash line is the y equals cos x, although that looks like the letter G. Okay, one last graph to graph, and then you're gonna have the rest of the period to work on your stuff. And this is cotan. Good news is cotan's trig table was huge to begin with. And so there's no difference here. So we're just going to go through and we're going to do the reciprocal of the y values only. So this is going to be undefined. So anywhere you see a 0 in this table, it's going to be undefined. 1 just reciprocates to 1. If it was an undefined before, it goes to 0. -1 is -1. 0 becomes undefined. Just gotta make sure my fingers are lined up. 1 is 1. Undefined becomes 0. -1. Do you see the pattern again? The pattern is happening. 0 was at 0, so that's undefined. 1, 0, -1. I think I'm going off the page here. Undefined, 1, 0, -1, undefined. All right, so as you can see, there's been a shift. Our asymptotes are moving over. Anywhere there was a 0, it's now an undefined. Anywhere there was an undefined, it's now a 0. So they're flip-flopping places. All right, let's get that graphed. Okay, so I got to put in my quarter pies. So there's my halves. Now half of half is a quarter. All right, gonna lay my asymptotes on first because that helps my brain be happy and it helps me not cross a boundary if they're on already. And again, you're gonna see in sinusoidal graphs and trig graphs, you're going to see that there's lots of patterns, repeating patterns, and that's that sinusoidal wave. So if you can catch on to the pattern, you don't end up having to do a ton of math. And sometimes it's easier to see the pattern when they're nice numbers like pies, like this one is. My asymptotes happen at pies. Okay, those look a little straighter. That's an improvement. I'm going to put on my values. So at negative 7 pi over 4, that's the one closest to there, I'm at a positive 1. And then I'm at a 0, and then I'm at a negative 1. And then I have my asymptote, and then I'm back at a positive 1, a 0, a negative 1. Asymptote, positive, 0, negative. Positive, 0, negative. All right. So, oh, that works way better. I'm so much better at graphing cotan graphs than I am tan graphs. It just seems more natural. Your asymptotes have to be heading towards, or sorry, your graph has to be heading towards those asymptotes. All right, so I don't know if you remember from the other, oh, look at this. This works out so much better when I have it on 2 different pages. The tan graph, I said, started 0, 0, and it rises to the right. This one, the tan graph actually starts at, the cotan graph starts at pi over 2 and 0, and it falls to the right. So it does the opposite. So like I said, just similar enough to cause you anguish and confuse you, but you do have to keep them straight. Like I said, 6 graphs are all fair game for exams and tests and quizzes. You really do need to know them. And then I'll be terrible and horrible person and mean to you, and I'll put transformations in them as well. So if you know the basics graphs, the transformations aren't a big deal, but there's still some more stuff to do here. Okay, let's fill out the table. The amplitude we said is none because we don't have that top of the wave or bottom of the wave. Period. The period, we see all of it between pi. So from 0 to pi, we see all of it. So my period is just pi. And if you notice, if you remember on your tan graph, your period was also pi. The domain. So again, I'm going to do my asymptotes first. So theta can equal, sorry, that should be an equal sign. Theta can equal, my very first one is at 0. So 0 plus pi k, where k is an element of the integers. So when I do my domain, theta can be any value except where I have my asymptotes. So I switched that up, right? I put the 0 in this one, I didn't put the 0 in this one. Means the exact same thing. It's not an issue. So range was nice and easy. We can hit any value. So it's those. Sorry, I'm doing this right at lunch. Did you know bells have a duration of 10 seconds? That's what I can tell you. Warning bells have a duration of 4 seconds. Okay, zeros are the function. Just like on our tan graph, we've got lots of them. So we have to create a general solution for them. So my first 0, my first positive 0 happens at pi over 2. So I've got pi over 2 plus My next one happens at pi k, where k is an element of the integers. Y-intercepts, we have an asymptote right on the y-axis, so there is none. And again, don't leave those questions blank. Make sure you fill it in that there is no y-intercept or no amplitude. Okay, so that is your cotangent graph. That is your last graph of the six. That's your last graph of the six that we've done. So now you're going to have the rest of the period to complete the assignment. Tomorrow, when I come back, we're going to start the trig equations. Those ones are a little bit more difficult, so it would be super helpful if you had some practice graphing. I hope you guys had a great time, and we will see you very, very soon.